This is again, I'm a singer, internet voice. This is your vlogger, science vlogger, and OSH, occupational safety and health vlogger, social media influencer, and small YouTuber. Welcome back. This is Uncle Junjun talks about pure sciences, and this time gonna be linked to organic chemistry. So we discussed a lot of functional groups a while ago, right? So if you can remember, the most common are carboxylic acid groups, the alcohol groups, the hydroxyl groups, like that, amino group, carbohydrates group, protein group, amino acids group, like that, acetyl, amide, amine, whatever. But now we need to introduce another groups, functional groups in organic chemistry that are not really that familiar for us. Okay, so we have the acyl. But actually this acyl is the general term of esters, okay, aldehydes, and ketones. Okay, it's a combination of that. Then we can say that's an acyl group already. If you can see that in a formulation, something like that. Okay. Number two, we have the aryl. Okay, the Aryl. The Aryl is special because you need to consider the ring structure. For example, if you have the benzene, okay, we have 6 atoms of carbon and 6 atoms of hydrogen. The benzene have a ring like this and a circle like this. This is a symbol or a pictogram of the benzene. Oh my gosh, feedback also again, the microphone. Okay, now we have also the toluene. Okay, what's the difference between toluene and the benzene? So it's gonna be C7 and HA. Okay, when I researched it also, I found it errors. I don't trust also the Google because it errors. There's an error, guys. It's put there C17H18. I think that's a clerical error. It's not 18 because it's near to benzene to toluene. I hate it. Okay, Google in the internet. So this 18 is only applied to usually for gasoline, an alkane that contains octane, 8 atoms of carbon and 18 atoms of hydrogen that runs our car, gasoline. But why carry in the 18? So this become non-existent. So it's not correct. So it's only C7H8 is the toluene. Oh my gosh. And the toluene pictogram is like this. The same with benzene, but you have to attach the CH3 here. Something like that. Okay? Ganon. Then if you remove the circle, chuba, chu, it will become like this. Okay? There are 3 double bonds. Okay, and you attach the CH3 here. If it is toluene, like that. And if this is not a toluene, then you will never attach the CH3, which is the benzene. Okay. Now, the aryl, guys, principle, you need to lose the hydrogen attachment of this ring and produce another product. So it is expected that the hydrogen will be lesser or will be taken out in the ring. So that would be mean by aryl. Okay. And that's very clear, right? So the corner again is carbon. Okay, there's no involvement of nitrogen here. Only carbon and hydrogen. So basically, these are all hydrocarbons, right? But in a ring. So actually, this is, we have the open chain and the closed chain, right? You can remember this one. Okay. And then we have the aliphatic. Actually, there are 2 types of hydrocarbons based on my memorization before 20 years ago. We have aliphatic, okay, and aromatic. Okay, correct me if I'm wrong, because this is only stock knowledge. When you say aromatic, it involves ring, just like this benzene and toluene, or maybe reverse. I'm not saying I'm correct because this is on the spot. Okay, then aliphatic is only carbon and hydrogen banded together. There's no ring. The general formula only structuring the formula. So basically, hydrocarbons composed of 2 types of structuring the chemical formula. We have aliphatic and aromatic, something like that. Okay. Then both aliphatic and aromatic, we can distinguish that by an open chain and a closed chain. But literally, the closed chain will be aromatic because that is the benzene ring or the ring. Closed ring is the ring. A closed chain is the ring. Because this is polygon, it's closed, there's no opening. But obviously, this closed chain. Open chain will be the, like this only carbon, hydrogen, carbon, hydrogen, carbon, hydrogen. The simple way of structuring the carbon and hydrogen is open chain. So, this aliphatic is mainly open chain. Aromatic is mainly a closed chain. So, it contains a ring. And then, the basic here is the benzene ring. Okay, you got the point. For the hydrocarbons. But if you talk about the other products, such as nucleotides, amino acids, there could be a pentagon there. Pentagon, not only the ring. But we are dealing here exclusively with hydrocarbons, man. Carbon and hydrogen. So we are limiting only to C and H, not involving the nitrogen, whatever. But what I mean in the protein synthesis, nucleotides, nucleic acid, there's also pentagon there. Okay? Pentagon. Such sugar. Like that. Okay? Sa mga pentagon katong mga kuan, mga fructose. Diba? Pentagon man na siya. If you try to get the aromatic formula. Okay? For fructose. Diba? But I cannot explain that here. Okay, I will explain na lang. Charot. Okay? Para na. Isang fructose guys, ana na siyang fructose guys ha. Pentagon, the oxygen deliary, okay, ganon. OH, ganon. And then CH2 deliary, and then CH2 deliary. Okay, like that. Okay, dan naman nagpagawas na OH. So, OH, OH, ganon, OH here. Okay, 1, 2, 3. So OH here, this will become H. And then here, OH and H here. Namakita man na guys, good kung imong ipares ang OH, H ang baliktad. Okay, if you put the H, the opposite will be OH. Okay, if you put the CH to OH, either you put the OH or the H. But be sure the other H is already distributed the other side so that you can put the OH. Something like that. You got the point? Anak siya. Okay? Di man pwede magdubli-dubli. Oh, diba? Ganon. Mga palangga. Mga kaloka. Okay? So, nasabtan na nato ang kuan. Fructose. Okay? Okay? Muna na siya ang fructose, guys. Okay. Nakakaloka. Yung fructose, di mo naman itong topic na ito ng chinisbutan ng fructose, ha? Okay. Common pa na siya sa kuan, fruits. Sugar in the fruits. Ano ang fructose? Talaga. 1, 2, 3, 4, 5, 6. Because this is hexose sugar man siya. Okay? Ganon. Ana. So, nasa ikaduhang band yung double band sa oxygen, ana. Then OH, H, H, H. Ganon. Nagyan po sa carbon number 3, ang imong OH sa left. And the rest, baliktad na siya. Ang double bond nasa imong carbon number 2. Ganon. Here. Here. 1, 2, 3, 4, 5. Okay. Our carbon number 3. 1, 2, 3, 4. Okay? Ganon, anak. Oh. Muna na siya imong kuan. Fructose. Okay? Muno sa karans ang fructose, guys, ha? Okay. So, gano'n siya. Okay. Kuha na tana. Okay. Arito sa, sa acryl. Laway ko si acryl sa pero acryl. Di ba? We have acrylic acid. Okay. Natay acryl. Okay. Acryl group. Ang mga acryl group, ito ng mga acrylic, is the simplest unsaturated carboxylic acid. Simplest, okay, unsaturated carboxylic acid. Okay, carboxylic. So, kung carboxylic, nasa siya OH. So, the general formula will be like this. CH2 double band CHCOOH. The COH is the carboxylic acid group. And the CH2CH is your acryl. But the thing is, you have to attach all the time the COH because you are saying acrylic acid. Okay. But if you put not acyl here, you'll change your name. Okay, to acrylic chuba-chuchu, acrylic to blah blah blah. Because this is only the attachment here. It happens only in our example, acid is the attachment. So acrylic acid. So there's a double bond here. Okay, so what comes in our brain cells? Acryl have double bond always? Yes. One double bond here in the center. Okay? So actually, ganito yung one double bond, muna siya acrylic. Ganon. Yeah, yung ipon ng carbon. 1, 2, 3, there are 3 carbons. Muna siya acrylic. Okay? Ano ang acrylic? Walay dagang asakali. Okay? So, muna siya acrylic. So, ito na, the simplest unsaturated fatty acids. Meaning, it's also good for the health. Unsaturated man siya, diba? Okay. Diba guys? Muna siya metabo. Okay. Now, we will discuss the toluene. Okay. Toluene is very common. Chemicals, right? Organic chemical, toluene. Okay. As I told you, like this, the toluene, like this. Hexagon. CH3 here. Okay. So, it's the same thing we should have put here already because this is carbon. Okay? But if we need to emphasize, it will be like carbon, 1, 2, 3. And there's also H here. 1, 2, 3. There's also H here. 1, 2, 3, H here. 1, 2, 3, H here. 1, 2, 3, H here. Carbon in the corner and H attached to it because carbon has 4 single bond. Like that. And this double bond here is counted already as 1, 2, 3. Ganon. 4, O. Another here. 1, 2, 3, 4, O. Another here. 1, 2, 3, 4, O. Another here. 1, 2, 3, 1, 2, 3, another here. 1, 2, 3, another here. Because carbon has 4 bonds. 4 single bonds. Okay? But no need to put because it's understood. Okay? So muna siya ang toluene. You get the point? So, toluene is also known as methyl benzene. Okay? Because this metal is attached in one of the carbon of toluene. So, methyl benzene. Okay. So, methyl benzene and toluene is the main raw material of paint thinners. Sa mga paint. So, if we manufacture paint, you can always put toluene as our raw materials. So, for paint thinners. Okay, like that. This is for toluene, right? And how about benzene? So benzene, no need to put CH3. Okay, this is more simple, but the same ring, like this. So meaning C6H6. Okay, get the point. Anak siya. Then toluene is C7H8. Okay? Ganon. Okay. So benzene, the more we produce benzene production, it will be used in the styrene production as the raw material for producing also polystyrene. Okay, making plastics and polymers. Okay. So the plastics we have in front of my here have also this one, plastics. The raw materials there are having benzene, okay, converted to styrene later. And then it will become a polystyrene to be used in the polymer industry and in the plastics industry. So, different ang toluene because toluene is used in the paint thinner, paints. Okay, that's toluene raw materials. So, klaro kayo diferensya. Benzene plastic industries, toluene paint industries, raw materials. Okay, now styrene formula, what is the formula of styrene? It's C8H8. Be careful, that's very tempting to gasoline. Right? Because C8 and H18, but this is only 8, there's no 1. So this is styrene already. Okay? Ganon. Styrene. So if you put close and open parentheses, mga palangga kumitad, take note, this is polystyrene. Poly of anything. Okay, you get the point. Like this, toluene. If you put close and open parenthesis, small letter n, this is polytoluene. The rule in organic chemistry. If you put open close parenthesis n, this will become polystyrene, meaning styrene banded together, toluene banded together, things like that. Okay, the symbol like this, ha? Ganon, diba? Okay, so we can understand. Now, we have another one also. Okay, so if we have this, we have also the phenol. Phenol is an alcohol derivative of the benzene because there's a ring in there for the phenol. Okay, like this. Ring, 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 chuba, chuchu, and OH. Tick, 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 ganon. Diba? So OH, meaning this is, example is, this is now already phenol. Okay, the alcohol of an aromatic benzene. Okay, or ring, something like that. Phenol or na siya OH. An alcohol version of a ring aromatic hydrocarbon, something like that's phenol. Okay, you get the point. Now, if you attach this to, let's say, alkane, it will become phenyl. Okay. But if you don't attach that to anybody else, as that all, it's phenol. Okay? Meaning the phenyl with L, meaning there's an attachment. If no putting L, that's already the standard formula. Okay? You get the point? Aryl, acyl, acetyl, alkyl, carboxyl, meaning needs to bond at the corner. Munang naputol siya ang ani. Okay? So it needs to react with other compounds. Okay? Muna siya. Okay. Now, we have related this, we have the cumin, C9H12. Okay, this is the formula of cumin. Okay, you get the point. Then, we know that before toluene, right? Toluene is for paint thinners. Cumin also will be used also blended to toluene to make paint thinners, to make a proper proportion. The cumin also, not only the toluene. So we need to say C7H18 toluene plus cumin C9H12 will be the raw materials in making paint and thinners. Cumin. The cumin is so special. It has also another application. So cumin plus phenol will create now an acetone. You need to say cumin and phenol are raw materials of acetone also. Okay, so this kind of ring I told you. You will see directly that the application of phenol will be in the production of acetone, kalas. Okay, so this is gonna be like this. You got it clearly? Okay, benzene. Okay, benzene production can produce styrene. Okay, C8H8. And then it will be bonded together to form the polystyrene. Okay? You get the point. And after that, it will make the polymer and the plastics. Okay? You get the point. Ano na siya, guys, ha? Okay. Then, your cumin is also the material of making the paint and thinners along with the toluene. The same thing. Okay? You get the point. And your phenol is the raw material of making acetone and also the cumin. Okay, you get the point. So, meaning to say, we cannot make plastics without polystyrene and benzene. Okay? Actually, the significant is the ethyl benzene. Okay? But we normally take the benzene as a standard representative of all the benzene family, something like that. Okay, this also with the benzene, but benzene will be the representative of their group, something like that. Just like a family, you will send your son to represent the meeting, just like that. Okay, so that's why I tell benzene will represent, but the specific way is the ethyl benzene. Okay, for the production of benzene, it will become ethyl benzene to produce styrene, and the styrene will be coupled together and then used for polymers and plastics, something like that. Ito dapat mga palang kita. Okay. Thanks. So, any questions so far? Wala ko nilabot ko itong mga Tupperwares, ha? Tupperwares, itong mga polycarbonates, carbonates, because that's also there's also raw materials. Carbonates are raw materials of making Tupperwares. Okay, and plastics and lunchbox, something like that, or whatever that you can see in the market. Food lunchbox and blah blah blah. And also another is the HDPE and the LDPE, low density polyethylene, because polyethylene also are plastic that is, special in characteristic that can sustain higher velocity fluid, and it will never go rusting, it will never be corroded. Okay, the density polyethylene. Okay, pipe, kinds of pipe, HDPE and LDPE, low density polyethylene and high density polyethylene, and also the PVC, which is the common one, the plastic pipe we have in the plumbing of our kitchen, our toilet, right? The orange or whatever, that is PVC, polyvinyl chloride. Okay, so polyvinyl chloride. So the vinyl chloride are banded together to make how many vinyl chloride? That is poly. Poly means there are a lot of vinyl chloride banded together in that particular molecules. That is poly. That's only putting at the prefix. Okay, it's like pre, post, re, d. Magano-ganon, di ba sa English? Okay, get the point. So, muna siya matabo. So, mga plastics pala, PVC, polystyrene, styrene, mga ganon. May mga puli-puli siya chucho, except sa HDPE and LDPE, and the carbonates also. Okay? Because these Tupperwares are plastics mainly also, belong to the plastics industry. Okay? Get the point? Whether transparent or colorful, plastic materials. Okay. I think including also the rubber for this, the rubber band, something like that. Okay, anything that is having a high elasticity and to be stretched, mostly contains of this kind of chemicals. Okay, that's the point. We learned this because we have chemical process industry subjects and we can still remember. Okay, basic, not the complex one. Okay, so subjects din na siya sa chemical engineering, ang mga chemical process industries. Mga products na they-produce different companies all over the world. Talking about different kinds of substances, for example, shampoo, soap, like that, okay, blanket, pillow, textile, anything, cans, rubbers, plastics. We have one subject for that in chemical engineering that only focuses on the raw materials and the products, how it is being processed. Okay, including the beer, like the whiskey, like that, blah blah blah, so many guys. Okay, and the book is just a very thick book like that. I remember the color is black, and color also of organic chemistry book is red and white. I could still remember really. The chemistry by Friedmore is orange, and there's a little bit of design like light blue. Ganon. And then our chemical engineer's handbook is like a deep violet and black also. The latest version is the deep violet, and the old version is black, the cover. Because it depends, 6th edition, 7th edition, 5th edition, 4th edition, like that. It depends on the edition, what color. But in my part, I have the black. Okay? Like that. You get that point. Every time when I do notification, I still scan that every time. Okay? Even though nobody pushed me to do it, because I need still to read, like that, blah, 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 so and so. Okay? You get the point? Malinaw ko magtala sa akong handbook, because I love it perfectly. Something like that. Physical properties, like orange marker, like this, colored pink, colored green, so that I can easily scan every time. And I love it perfectly with colors. Nakakaloka. Diba? Ako siya hindi sa tagsabutag mga kuan mga physical properties, chemical properties, boiling point, mga ganon, di ba? Specific heat capacity, ganon, heat capacity, nakakaloka, viscosity, all physical properties. Imong siya tagsabutag ulit ito, baga kay siya guys. Imong labilan, pa di ka maglibog ini ka pakit-paklik asa ka busod. Okay? Ito yung mga steam tables, mga ganon, saturated vapor, superheated vapor, ganon, nakakaloka. Okay? A lot. Okay? So, any questions so far for this topic? Thank you so much for watching. See you later for another topic. Bye-bye. God bless everybody. See you later. And then don't forget to subscribe my YT channel, and also click notification bell for some news updates at Singer Journal Voice. That will be all about Acryl, Acyl, and Aryl special groups in organic chemistry. Bye bye, everybody. Huy, ganon.